Hello students, welcome back. So in this section, we'll be looking at the cone. So the cone, just like the relationship between the cylinder and the prism, mathematically they look the same, but by definition they are different because a circle is not a polygon. So similarly, the cone, when it comes to the calculation of the cone, it is quite similar, okay, to that of the pyramid. However, a cone is not a pyramid for the same reason, because a cone has a circular base and a circle is not a polygon, so it is not a pyramid, right? So but the points, some of the definitions are the same. The point at which they meet together is called the apex, okay, and you still have the slanted sides and the height and so on, right? So yeah, is a cone a pyramid? The answer is no, it's not, right? Okay, so the volume of a cone works the same way as the pyramid, so we know that it's going to be 1/3. Okay, and since we already know that the volume of a cylinder is pi r square h, so the volume of the cone will be 1/3 pi r square h, right? So very straightforward over here. Now the surface area will be interesting though, because when you look at the net of a cone, you don't find triangles anymore. In fact, what we see is a sector, right? A sector of a circle, and this time round, the slanted length of the cone, as you see, becomes the radius of this sector, right? So what happens is, if you can visualize, we take this sector, okay, we break it up, we slice it apart, and then we alternate them. It will eventually tends to become a rectangle, right? Now there is also, this is a visually how we can actually prove how the area of these lateral sides of the cone. There is of course a algebraic proof, which I can show you in class in person when we meet in the classroom, right? So do remind me, I'm very willing to show you that as well. Okay, so moving on. So now that we understand that, let's see how it works. Okay, so the curved surface area, right, is the area of the rectangle. And if you look at the rectangle, refer to your handout, okay, the length, okay, the height of the rectangle is, we use the letter L to represent the slanted height. So we have the slanted height L, and then we have the pi r on the other side, right? So what happened is that this rectangle, they come together, they will create pi rl, okay, which is actually the area of the slanted side of the curve, okay, and in cone we call it the curved surface area. Let's follow the same terminology. Okay, so the total surface area of the cone will be area of the circle, which is pi r square plus pi rl. There we go. Okay, once you understand how it works, it's not that difficult to remember the formula. So here we have a question, a pretty interesting one, right? We have a frustum, right? So basically it's a pyramid where the tip is actually cut away. So what happened is, it is a shape made from a large pyramid, cone. Let me say that again, I've been saying it wrongly. So it's a large cone, subtract the smaller cone at the tip, right? That will give us the frustum. So what we need to do, we need to find the volume. So we need to find the volume of the large cone minus the volume of the small cone. Makes a lot of sense. However, the challenge for this particular question is that we do not know the height yet, right? So let's find the height, right? So what I'm going to do is, I'm going to look at, let me use a different color because it's already red on the screen. Maybe green color, right? So from the tip, the apex, right? This height is the height of the small pyramid. Maybe we can use this, right? I'm going to call this h. So I'm going to say, let the height of small, I keep saying pyramid in this video, it's cone, all right, of the small cone be h centimeter, right? So with this, what's going to happen is this, right? Here's something that some of you may be able to see, but some may not. So let me show it to you. What happens is, if you look at the side view of this cone, okay, side view of this cone, this is what's happening, right? This is a side view, right? And there's 20 cm here, it's 90 degrees. And the small cone here, right, it is 5 units, 20 units. Now this portion here is H. This portion here, okay, is actually 12. Therefore, using the property of similar triangles, right? This yellow triangle over here versus the orange one over here, right? Okay, I basically just color everything here. Well, not the best use of highlighter, but let me try again. Maybe use a different color pen. You may be able to see it, right? The H, okay, I'm writing in red, right? Over 5 is going to be equals to, let me use purple, H plus 12 over 20. Okay, because of the property of similar triangles, right? So from here, we can actually write down in this way, H over 5 is equals to H plus 12 over 20, right? So from here, we can actually find the height, the H. So cross multiply, 20H equals to 5H plus 60, 15H equals to 60, H is equals to 4 centimeter. So the height of the small cone is 4 centimeter, right? So once we have this information, we can go ahead and solve this question. We want to find the volume of frustum is equals to the volume of the larger cone, which will be 1/3 pi 20 square, which is a radius, times the height. The height is actually 4 plus 12, right? Minus away 1/3 pi. This time round, the smaller cone, the radius is 5 units, so 5 square, and the height is 4, right? So from here, just use our calculator, press it carefully. You have 6597.345. Let's write it is in 3 significant figures, which is 6600 cubic centimeter, rounded off to 3 significant figure, right? So that's one way we can do this. But we have another example on cone, so let's take a look. Here we have another cone, right? This time round it has a slanted height of 10 cm, and we want to find the total surface area. Sure, right? So applying the formula again, total surface area is going to be equals to pi r square, which is the base, plus pi rl, right? Pi, r is 6, l is 10, okay? Which is equals to 301.59, okay? And end up as 302 square centimeter when corrected to 3 significant figures. Okay, now this question is interesting, right? So of course the idea of this example is to practice applying the formulas, but if I want you to find the height of this cone, are you able to do it? Pause the video and think for a little while, and when you think you have the answer, you can actually unpause. All right, yeah, so same idea as the previous example. We can look at it from the side view, and when we look at this cone from the side view, we actually see right angle triangles, and that means we can actually apply Pythagoras theorem to find the height. So that could be one thing to keep in mind, and you'll probably see them in some practice questions I'll give you in the future. All right, so that's about cone. I hope you understood what's going on. All the best. Next section, we'll be looking at the sphere.